Okay, hi, welcome to the session. Thanks for coming. My name is Christy Giffrin. I'm a Senior Marketing Manager for AWS. I work on the serverless team. Today we're going to talk about modern application development. Let me grab my clicker. Okay. And I kind of gave away the whole point of the presentation in my title. So the focus of the presentation today is, as I said, around modern app development. And if you look at the track, the serverless track, you're going to see a lot of related sessions around this topic this year. So if any of the things I'm talking about today seem interesting or you want to dive deeper, there is a ton of other sessions. So this is intended to be a higher level overview of how we see modern application development. So first things first, why do we need to accelerate innovation? So there's actually no historical precedent for the pace of change that we're seeing right now. And actually, if you, Klaus Schwab, who is the chairman of the World Economic Forum, wrote a really interesting paper around the fourth industrial revolution. And if you have time to read it, I really suggest you do. But the point is that everything is changing at a really fast rate, much faster than it was, 5 years ago. And companies are becoming increasingly global. Products are becoming completely digital, and that's really causing a lot of disruption in virtually every industry today. So as well, customers' expectations are getting higher. They have the power of information and choice, and so now the customer experience is really at the center of the economy and driving what we do because it's about better serving our customers. Businesses have to be agile in order to adapt to that constant pace of change, and that's what we're really talking about today. Because if you aren't able to innovate fast enough, you risk being left behind. And when this happens, it changes what it means to compete and to be competitive. So competitors can rise, from obscurity, you never heard from them before, and to dominance in a couple of months. And it's whether or not you can react to that fast enough. Some incumbents are left scrambling, trying to figure out what to do. And at the same time, leaders need to differentiate their current revenue-generating products and what they're working on for the core of their business through continual innovation and incremental innovation, right? We still have to make our numbers, regardless of the fact that this is going on. But at the same time, we have to invest into incubating new ideas so that we continue to stay ahead of the competition and we're not catching up. So that means that competing today really relies on agility. Now, companies that are doing this well are putting technology at the core of their business strategy. I remember discussions with clients a few years ago. I was a solution architect for a large part of my career, and I very distinctly remember talking to customers, and they were complaining that IT was a cost center. And I think that's really funny now, because IT has not only moved to be a profit center, but I would say an investment center that's contributing in a meaningful way to revenue. And when our core products and services are code, that's an opportunity for us to position our software as a competitive differentiator. And companies that are accelerating their business strategies are doing that in order to remain competitive. So thousands of small startups are doing this, but so are large established companies. So you've got manufacturers that are digitizing their products, manufacturing and supply chains. You've got retailers that are transforming the role of stores for customer engagement and loyalty programs. Banks are building digital platforms for commerce and embedding their services into partner services. And media companies are ramping up on-demand entertainment services. So let's look at a few examples, just at a high level, of what that looks like. So first, you can obviously create new products and services that create new revenue streams. So for example, we at Amazon created Alexa. Netflix is streaming original content. Companies are also using APIs and digital platforms to deliver a core competency. So for example, Stripe provides a payment service that allows anyone or anything to exchange money safely and easily over the internet. And then other companies are creating digital marketplaces. So whether it's Airbnb or Salesforce or Amazon.com, for example, at Amazon.com, we enabled third-party sellers. So we allow them to position their products on the website, and we handle the transaction. And this is connecting buyers and sellers in new ways and creating outcomes that actually weren't possible before. So if you like, you can come to Vancouver, BC, and you can rent this condo through Airbnb. And that's a very different experience than renting a hotel in Vancouver. And let's not forget the value of data. So for our customer, the Financial Times, maintaining a high level of satisfaction with their customers is key, and it depends on making accurate, meaningful decisions as quickly as possible. So they run analytics for their 450,000 subscribers, and that enables them to make decisions like what to publish, what subscription options to offer, and so on. And when you look at something like IoT, companies are adding services to products. So if you look at someone like John Deere or DuPont Pioneer providing precision agriculture solutions so that the growing of crops is more accurate and controlled. And then this can sometimes change revenue from product to service or subscription. And even shaving is digital now. So the Dollar Shave Club, recently acquired by Unilever, allows you to order razor blades on subscription. And by direct connecting with their customer, they're focusing on serving a very specific customer need, and they're doing it well. So we see that a lot of companies are investing heavily in innovation to help them engage, compete, and grow. The next question is, how do you enable rapid innovation? Companies need to deliver better customer experiences and to be able to act quickly on disruptive opportunities. We want to deliver those new outcomes before the competition, all while we're minimizing our costs. So often, disruptive ideas can sometimes seem really bold, and a lot of the time they'll seem wrong. And a lot of the time they're going to fail. But in order to innovate quickly, we need to be comfortable with that. And we need to know when to persevere and when to pivot. So if you can do that, you can create a pipeline of viable opportunities and anticipate the market instead of reacting to it. So the goal really, when I talk about being comfortable with failure or failing, is to enable your teams to experiment. Take measured risks, and as our CTO, Werner Vogels, likes to say, let your builders build. At Amazon, we think of builders as people that reinvent the customer experience. But not only that, they're empowered to actually change the customer experience. So when you launch a minimal viable product, and in actuality, it probably should be a minimal valuable product, it accelerates learning about what your customers need. MVPs can be rough, they can be incomplete, but they're good enough to test assumptions. And customers will tell you whether or not it enhanced their lives or whether or not it met a need of theirs. And if you can quickly take that feedback, iterate on it, that's really what we're aiming for. This process of experimenting, iterating, listening is going to turn uncertainty into discovery about what will work. So the first step that we see a lot of customers take when they're trying to move towards innovating at a faster pace is adding cloud capabilities to their applications. So there's a few ways we see this happen. So when a company is looking to scale their migration to the cloud, a lot of the time they're just going to rehost their application. So that's moving the app to the cloud without recompiling, altering the code, and not altering any functionality at all. Apps are easier to optimize once they are in the cloud, partly because your organization has developed some better skills by doing that, and partly because the hard part, the migrating of the application, the data, and the traffic has already been done. Now, with replatforming, you might make a few optimizations in order to achieve some tangible benefit, but you're not really changing the core architecture of your application. So you might be looking to reduce the amount of time that you're spending on managing your databases or your messaging. So then you might look at using something like Amazon Redshift or Relational Database Service, or Amazon MQ to offload that work. You might migrate an application to a new runtime platform, or you might decide that you want to move VMs that are in the data center to containers in the cloud. Or you can migrate your application to a fully managed platform to something like Amazon Elastic Beanstalk. Now next, we see some restructuring and optimizing of existing code using cloud-native features. So this is without changing external behavior, but it's typically driven, again, by a need to remove technical debt, to add features, to add scale, or to improve performance. And also when it's typically difficult to do that with the application in its existing environment. So for example, customers often might look to migrate a monolithic application to a service-oriented architecture, or to boost agility, and again, to potentially improve performance. Now, many customers gravitate towards, and especially when you're looking at startups, building net new applications in the cloud. And even enterprises and established organizations might look to extend what they already have by adding new native cloud capabilities and on top of that and connecting to it. So whatever approach you take, what I want to stress about this graph is that there is no one right way to do this. It depends, every customer is unique, every application is unique, but there are lots of options. And the main point here is that there's lots of steps that you can take that get you incremental benefits. So this is all enticing. Hopefully it's all where we want to be. But it turns out it's actually hard. When we look at all of our customers and we look at our own experience, certainly they have very complex environments and challenges, but there are two things that tend to come up over and over again. So the first is that they want to devote time and their resources to what really differentiates them, to free up capital, to lower risk, to invest into innovation. But another priority is trying to understand, how do you make that shift while respecting your incumbent systems and what you already have? I'll say classic applications instead of legacy applications. Everything has to work with and augment what you already have without creating new problems. So based on our own experience and by observing and listening to our customers, which is actually where we learn the most, we've identified a set of best practices for enabling rapid innovation. These aren't prescriptive. They're not meant to be applied in any order. We agonized over using bullets instead of numbers. They're not binary either. So these happen in continuums and degrees. The best practices that we're showing here are what AWS and what our customers use to deliver better customer experiences. So these best practices do a few things. They empower builders to build better customer outcomes and enable safe experimentation. They let us protect the customer's data, and the business. They enable us to identify and address any issues with performance as quickly as possible. And by moving in this direction, we can create that business agility that we're looking for through business simplification. We can focus on what differentiates our organizations while lowering costs and reducing risks. We can reuse what we have. We can build faster. We can deploy more features quickly and more frequently and shorten our time to market. We can increase developer productivity and maximize our use of standardization as well as automation. And ultimately, what this means is that we're removing any and all impediments to getting our software out the door as quickly as possible. So these best practices enable rapid innovation, and they're the foundations of how AWS approaches modern application development. The best practices deliver our goals to increase quality, agility, and velocity for the business. So let's dive into how you can implement each of them on AWS. So I mentioned that the best practices now allow us to increase agility, velocity, and quality. And at AWS, using microservices lets us continually enhance and improve our services based on customer response, usage, and needs. Building with oops, went too fast there. Back one more. Building with microservices architectures lets us leverage and extend an application's value, and it enables us to rapidly introduce and iterate on new features and services for our customers. So now you know what agility is. We achieve agility through serverless. We see serverless as composable infrastructure blocks that are free of the low-value effort that's usually associated with things like infrastructure provisioning and management. These building blocks are deeply interconnected with each other by default or through events. And with serverless, we can construct applications from the bottoms up, choosing purpose-built building blocks that are highly available and scalable and without operational overhead. So for AWS, giving developers operational responsibilities has greatly enhanced the quality of our services, both from a customer and a technology point of view. At Amazon, our philosophy is you build it, you run it. So that brings developers into contact with the day-to-day operations of their software, but more importantly, it brings them into contact day-to-day with the customer. This customer feedback loop is essential for improving quality of the services. And these three approaches here satisfy all of those modern application development best practices that I just showed you. So let's dig into the first one, componentization. So microservices are software applications, are monoliths, let's start there first, are software applications in which the functionality is interwoven into a single program, single platform. And with a single logical executable, if a developer must build and deploy an updated version of the entire code base in order to make any updates or changes to the system. Conversely, microservices are finer-grained architectures with each service doing one thing, doing it well. They're comprised of small pieces with well-defined interfaces that represent how our business actually works, which is really important. Microservices have minimal function, they're deployed independently, but they interact together to provide a larger business goal. So monoliths are simple to manage at first, and they have a lot of advantages. So we want to stress that we don't think monoliths are bad. Everybody has monoliths, a lot of our customers do. But over time, monoliths can also become a source of risk. Code grows as we add new features and more users. Code related to a specific function tends to sprawl all over the place. So everyone has monoliths, and they're not going away. The old saying applies, if it ain't broke, don't fix it. And on the flip side, everyone here probably or maybe has a system that's gotten a little too big, a little too messy, and then that's when you think about doing a little bit of refactoring. So one of our customers at Yelp was in this situation. They had a subscription billing process that was critical to the business. It handled recurring purchases. It was really important to them. But it was a decade-old piece of code, and it had grown over time. And they didn't actually really even understand what was inside of it. They wanted to make the system a lot better because they wanted to use new technologies, but because they didn't really, they felt there was some risk there that they were worried about. So the process that they used lived in 3 steps. And so they took the first of that step, which was billing of accounts, and they put that little piece into a microservice. And they used step functions to connect that service back to the rest of the code. So what that allowed them to do was to process multiple accounts in parallel, improving performance. But I think the most important thing there was that they carved off a little piece of the code, did it at their pace as opposed to creating a lot of risk for the business. They gained observability because they had workflow orchestration, and they essentially made their monolith act like a service. So microservices deliver all sorts of benefits, and I think probably everyone here is familiar with them. So I'm going to go through these really quickly. So the first is that different parts of your system have different needs. So when you use a microservice and you have multiple collaborating services, you can decide which technologies to use inside of each one. If one component fails, the rest of the system can carry on, and you have the choice to degrade functionality gracefully if something hangs or fails. Microservices also can make an organization's applications more secure because you have more granularity and more control. And each individual service has a smaller attack surface. So that makes assessing security easier and shielding critical resources better than traditional architectures. With monolithic applications, we have to scale everything together. And even if only one small part of the overall system is having a performance issue. Whereas with microservices, we just scale the part that actually needs to scale. And that reduces our costs while at the same time maintaining customer expectations. So large code bases tend to be maintained by large teams, and then with smaller code bases, we can use smaller teams, and they tend to be more productive. And we can really easily take our microservices and rewire them into new compositions for use in new different use cases. So that means our functionality can be consumed in different ways for different purposes. Now, when our individual services are small in size, the barriers to rewriting them or removing them completely are actually quite low. And many of our customers use microservices for that specific reason. And they're comfortable with rewriting a service when required and just killing a service when it's no longer needed. And a big barrier if you want to adopt new technology is the risk of doing that. So you can't easily change a monolith in that sense, but with microservices, you can identify a small piece of the system that has the lowest risk and experiment there. And lastly, you can deploy and change a service by itself without affecting the rest of the system. So you can change behavior in one place and release that change, more importantly, as soon as possible. And if a problem does occur, you can isolate it quickly to an individual service, making fast rollback easy. So at AWS, we firmly believe in the power of using microservices. We're very fixed on that idea. We've seen a lot of success from using them for all of the reasons that we just looked at. And as a lot of developers, application groups, security teams, and business units are excited about microservices too, because they give potential for faster functionality rollouts, more frequent updates, and the ability for different development groups to work together and release independently at the same time. But that being said, if you are using microservices, we need to think differently about a few things. So one of the most important things is integration. Integration is that connective tissue which is going to connect the microservices and create a living, breathing application. So services expose an application programming interface or an API, and all communication is through the form of network calls to enforce separation, to avoid having one service dependent on another. And that decoupling improves reliability. Getting integration right is critically important. Do it well, and your microservices retain autonomy, allowing you to change and release them independently. And integration is what lets us make the change to one service and deploy it without needing to change any part of the rest of the system. And it's also what lets us integrate with our existing systems on premises. So integration on AWS enables event-driven architectures, asynchronous and synchronous communication. Amazon API Gateway provides secure API endpoints that allow for communication and event-driven triggers between services. And with Amazon SQS, it's simple and cost-effective to transmit any volume of data between services without losing messages or requiring other services to be available. With Amazon SNS, services can fan out messages to a large number of subscriber endpoints for things like parallel processing. And with step functions, you can add resilient workflow automation to your applications so that you can connect and coordinate those services without having to worry about things like error handling, parameter passing, or state management. So I spoke about security a little bit before, and I'm going to talk about it a little bit more now because it's critically important too. We know that microservices have the opportunity to increase the security of our applications. And while I said each service has a smaller attack surface, overall we still have more surface area to cover. So the way we do that and the way we address that challenge is by automating security. So we have to ensure that our applications work as intended and only as intended, but at the same time, we can't slow developers down. We want to let builders build, but this doesn't mean letting developers run amok, and it also doesn't mean letting go of any of the control we need to have in order to stay secure. So securing apps in the cloud means moving security capabilities deeper into the software engineering space and addressing security throughout the entire application lifecycle, as opposed to specific checkpoints. Making sure that resources are deployed with security built in by building security into the development pipeline is referred to as DevSecOps. And after deployment, you want to make sure that the configuration you approved is still intact. That enables you to automate your security and to do any number of things, because the great advantage of the cloud is the ability to capture those automated events and notification of things that happened. So you can do things and automate things like detection, alerting, remediation, countermeasures, or forensics. And that makes it possible to continually evaluate your security again, without slowing your developers down. So as an example, FICO, they provide credit scoring and other services to 95% of the largest US financial institutions. And rapid innovation is key for them to stay a leader in their industry. But for many years, they lacked the ability to quickly develop and deploy changes to their solutions, especially their flagship Decision Management Suite, or DMS. They wanted developers to focus on being able to create new features, and so they wanted to start looking at how they could leverage the cloud to do that, including serverless. But at the same time, they still had to offer strong security and remain compliant with PCI, GDPR, and many other regulations, as you can imagine. So after evaluating their options, FICO moved DMS to AWS, enabling them to bring more innovation to the marketplace faster in that specific solution. And what used to take weeks would now be done in a day. To set guardrails around which code went into production, FICO uses a managed software development lifecycle to ensure that their customers' financial data is in compliance, using their own security tools in combination with those from AWS, and are able to fully meet their security and regulatory compliance requirements. So to gain the agility that can enable rapid innovation, we guide our customers to build microservices on serverless technologies wherever and as much as possible. To gain agility, you need to free up resources so that they can spend more time on the things that really matter to your business, and ideally lower operating costs so you can invest into innovation. By composing microservices with AWS serverless building blocks, you no longer have to worry about things like server and cluster provisioning, or OS maintenance, or patching, and so on. You always have just enough resources to get the job done, and you can choose what to pay based on, say, for example, consistent throughput or execution duration, depending on your need. So we refer to that as pay for value. And your environment is inherently available and fault tolerant. At AWS, we believe that a serverless approach is the best way to build microservices composed of these serverless building blocks. And Lambda is one of those services, which lets developers trigger code using serverless functions that automatically run and scale with high availability. And another option is Fargate, which provides rapid containerization of applications, allowing dev teams to focus on deployment automation. Now, a Lambda-based approach or a Fargate approach can be applied to virtually any use case, and our customers often choose to use them in combination, depending on their specific use case or requirements. And if you're interested in knowing more about how you make those decisions, there's lots of sessions, as I mentioned, related to that in the track this week. So modern apps also need data stores that can scale up and down quickly and persist data across all those services. Customers often leverage Amazon S3 for object storage to store and retrieve any amount of data from anywhere. And because traditional databases can't meet the flexibility, scale, and performance requirements that we need for modern applications, we have DynamoDB, which delivers consistent single-digit millisecond latency. And we have Aurora Serverless, which is an option for simple, infrequent, intermittent, or unpredictable workloads that's really cost-effective. And FINRA is a good example of how serverless can enable rapid innovation. FINRA protects investors and ensures market integrity through the regulation of broker-dealers. FINRA audits 99% of the equity trades and 65% of the option trades in the US and must validate stock data daily as soon as it arrives. They wanted to move their on-premises Hadoop cluster because it was hard to maintain, it only ran in batches, and it couldn't scale. And it was also idle 50% of the time. So using serverless building blocks like AWS Lambda, Amazon S3, Amazon SQS, FINRA developed a serverless stock trade validation system in less than 3 months. They increased their cost efficiency of the system by a factor of 2. They reduced their validation times from that used to be 7 minutes down to 1 minute, and they eliminated the management overhead that was associated with their on-premises servers. They achieved the scalability that they were looking for and collect and analyze billions of brokerage transaction records daily using AWS. So innovation actually ultimately comes from people. And when we have those smaller code bases maintained by smaller teams, we do improve productivity, as I mentioned earlier. And by bringing together all of the necessary skills to cluster around a product, you can move much faster and build really great things. At AWS, we found it's really important for our teams to have autonomy. When teams own the complete application lifecycle, including taking customer input, planning the roadmap, developing and operating the application, they become owners. They feel empowered to develop and deliver new customer features. Autonomy creates motivation. It opens the door for creativity and develops a risk-taking culture that's in an environment of safety and trust. And as a result, the team leads the team, and they progress collectively. So traditionally, software is delivered as a project. So we have a start and an end date. We have a nice list of features that we want to deliver, and it's completed by the end date, hopefully. A project is closed, and the team moves on. A product, on the other hand, lives on for some amount of time. It's an asset to the organization, and it evolves over time to better serve your customers. With a project-centric view, it's really easy to become focused on completing the project. But with a product-centric view, teams then instead focus on the product or service that they're trying to take to market. They feel accountable to the customer. And they work together to solve a customer problem, and then also can tie the efforts that they're doing back to a business objective. So Binder, they're an Amsterdam-based company. They enable marketers to create and find and use their brand's content on a single platform. Binder maintains an innovative culture in the company, and they really strive to create an environment that makes it easy for developers to innovate in order to give customers as much functionality as they possibly can. And as their CTO puts it, experimentation enables growth. So Binder uses Amazon Rekognition and AWS Lambda to improve their customer experience and speed innovation. They offloaded infrastructure management to AWS and introduced automation into their release process and saw growth of 200% year over year, and they decreased their time to market from 1 year to 1 month. So with more time to focus on innovation, Binder developers were able to create new services, helping them to expand their customer base even further. So there are a few things that you need to change about your application delivery processes when you're using serverless applications, and AWS has a number of ways to help with this. We have an efficient authoring and debugging experience for modern container and serverless applications, an automated continuous delivery solution that bakes in best practices and makes code changes safe, and a comprehensive set of application diagnostic tools that help developers understand and improve their distributed system performance. Now, serverless is unique for its ability to support a rapid pace of delivery while offering scalability at low cost. But to take most advantage from the agility that serverless can bring, it's essential to employ continuous delivery as well. With continuous delivery, code changes are automatically built, tested, and prepared for release to production. This effectively plugs infrastructure management into the delivery pipeline so that infrastructure stacks are updated along with any code changes. And CI/CD pipelines are designed for businesses that want to improve applications frequently and require a reliable delivery process, so they're a natural fit for modern applications. They're essentially the factory floor where we build modern applications. And automating continuous integration and continuous delivery is how companies can release high-quality code faster and more often. So with CI/CD, deployments are ongoing, and product owners can track the project and provide feedback at each stage. So when needed, they can seek realignment, make any changes needed, and adjust with the team. With this regular review and oversight, they feel more confident in the product, especially as it gets closer to the end users. Since the pipeline is providing feedback early and frequently in the development cycle, developers also know if something has gone wrong and can address it early, well before deployment, having ample time to make needed changes. With automated CI/CD, development is streamlined. Developers can be more productive because they don't have to worry about tedious and mundane things. The delivery cycle is shortened, so dev teams can be producing and releasing that much faster. Not only can they focus on what they love doing, which is building code and the best code possible, Fast feedback lets them iterate rapidly, make small changes, and see their efforts through deployment. The support and the validation that they get that they're producing a quality product directly impacts your customers. Now, what's surprising is that according to the Puppet State of DevOps report, less than 20% of DevOps teams are actually automating their CI/CD pipelines, even though fully automated teams reduce code errors by 5 times. Now, 44% is the really staggering number here. So if we think about a developer staff of 100 in Seattle, for example, getting 44% more feature output is the equivalent of increasing the dev budget by $11 million a year. You can use AWS Code Pipeline to model the full release process for building your code, deploying to pre-production environments, testing your application, and releasing it to production. Code Pipeline then builds, tests, and deploys your application according to that defined workflow that you defined every time that there is a code change. This allows you to increase the speed and the quality of your software updates by running all new changes through a consistent set of quality checks. So according to their CTO, Capital One realized about a decade ago that in order to continue to be a great bank, they needed to reinvent themselves as a digital technology company. And to do that, they wanted to build and architect their own systems and set up a developer culture to attract the very best talent. Their strategy is enabling more and more integration of their systems, increasing their ability to collect and get insights from customer feedback. But as their CTO puts it, insights are only as valuable as your ability to act on them quickly, and that's what DevOps helps them to do. They cut the time needed to build new application infrastructure by more than 99% by automating their DevOps practices. They attracted top talent, transformed their culture, and now they can start developing any new product as soon as they understand the intent behind it. Now, when we think traditionally of source code, we think of apps, websites, business logic, backend, transactions, etc. But in the cloud, all of these resources are expressed as code. And while to a human it's a configuration, but as we move through the application pipeline, other software and APIs of the cloud platform are going to turn that configuration into a running resource. By treating your infrastructure as code, you no longer make changes to live running assets. You change them in source control and let the pipeline test and deploy the updates. Modern teams model their environment in code and then manage that code using revision control techniques, such as aligning versioning, documentation, and configuration management processes. This allows you to distill the operational knowledge and expertise that you have in your teams into code, allowing someone who may not necessarily be the code author to safely provision and manage that infrastructure and set up a service in a manner that is manageable, reliable, and maintainable. So it's really that expertise that you've gained through your own experience and practice that you want to automate. And you can do that using AWS CloudFormation to describe and provision all of your infrastructure resources. With CloudFormation, a text file is a single source of truth for your cloud environment. And you can model and provision in a secure and controlled way all the resources for all of your applications across all regions and accounts. AWS also recently open-sourced a cloud development kit, which provides a framework for delivering cloud infrastructure and code for provisioning native AWS resources in order to fit into your preferred programming constructs. And that's available on GitHub if you're interested. Now, the Washington Post created a new source of revenue by creating Arc Publishing. It's a software as a service platform that enables any media company to take advantage of the same publishing platform that they use for their own newsroom. So in order to deliver better outcomes on that service faster, they migrated from a monolith to a microservices-based architecture, which gave them the power to use small distributed teams to innovate autonomously with low central oversight. Arc leverages CloudFormation to provision AWS Code Build and AWS Code Pipeline templates that teams start with in order to get up and running fast. Teams then have the freedom to customize those templates as they see fit, and they build their own custom workflows. The Washington Post has been able to keep their teams small and agile, ultimately making Arc Publishing a success, and are able to complete more than 50 deployments per day. So when you can and do push out multiple releases per day, like the Washington Post, you need as much visibility as possible to maintain performance and take the right action when you have to. This is more complex with microservices, because with monoliths, it's a very obvious place to start your investigation. It's just the monolith. But with microservices, again, we have more surface area to cover. We have more places to investigate. So while serverless means that we don't have servers to monitor, we still have multiple logs to sift through, multiple places where network latency could cause problems, and we need a system-wide view, not a service-specific view. Full observability gets us to answers quickly, and it requires metrics, logs, and traces. You can start by having your services expose basic metrics themselves, such as response rates, error rates, and so on. And the goal is to collect and aggregate as much of those as possible from logs to application metrics. Each service should track and expose the health of its downstream dependencies, and you can monitor the small things and use aggregation to see the bigger picture. Monitor the services and monitor the application. It's also really critical to know what healthy looks like, and you need to view the system in a holistic way. So Amazon CloudWatch will give you that unified view of your AWS resources, applications, and services, as well as your on-premises servers. It collects monitoring and operational data in the form of logs, metrics, and events, and you can set alarms, visualize the logs and the metrics side by side, and take automated actions, troubleshoot issues, and discover insights to really optimize your applications to make sure that they're running smoothly. For tracing, AWS X-Ray helps developers analyze and debug distributed systems and applications that are using microservices architectures. X-Ray will provide an end-to-end view of all the requests as they travel through the application across your services so that you can identify and address issues quickly. So by following these best practices for modern application development, AWS and our customers have been able to increase our quality, our agility, and our velocity, and deliver more value to our customers through rapid innovation. And to bring this all home, modern application development is really how AWS recommends our customers build applications. Modern application development practices are how we're able to invent and iterate at the pace that we do, and other customers have put them into practice as well, resulting in some pretty compelling business results. So all of the services I covered here today, I know are here today. I know some people get a lot of satisfaction from a stack. So we constructed the serverless track, like I said, to really cluster around these ideas. So for example, if you want to dive deep into observability on microservices, there's a session for that. If you want to understand how to choose the right compute option, there's a session for that. Or how to deconstruct a monolith, how to choose the right messaging solution. All of these topics, this is really the 50,000-foot view, but this is the detailed view is available to you as well. And in specific, or specifically rather, if you want to, this session was too high level. I know it's a really high level session. If you want the complete opposite of that, you can go listen to Tim Bray in his Inside AWS session. So Tim is our senior principal engineer, and he's going to dive into how we make decisions internally at AWS. So I highly recommend that session. It's on later today as well as tomorrow. And then our leadership team is sharing their philosophies around how we make decisions as well in our leadership session, which is Thursday at around 12:15. So in closing, every company in the world really needs to transform and innovate faster in order to remain competitive. And modern application on AWS enables agility and innovation in a really significant way, both for us as well as our customers. It changes an organization because it changes the number of people within your company that are thinking of new ideas, because they know that if they have an idea, they have a chance to see if it works. And that's a really powerful thing, and it enables them to take those new ideas to market faster. So I hope the presentation today gave you some ideas as well. I'm definitely ahead of time. I hope it gave you, if you want to ask a few questions, you're welcome to do that. Otherwise, recommend that you can find more information through the track as well as on the landing page here, Modern Apps. So thank you very much, and hope you enjoy the rest of the week. Thanks all.